My name is Jan Silverman, and I run this group within Spansion, bringing this product out. I should tell you, I am not a flash person. In fact, I never worked for a semiconductor company before until earlier this year. I am a server guy. I came out of Hewlett-Packard, Apollo Computer before that, if anybody remembers, and then into SGI, and then most recently Cray. So I've been all over the server business, and I really understand what high-performance computing and what it means to build a high-quality, very powerful server. So what attracted me to Spansion is what we're doing with Flash, and it is not an SSD. So go to the next slide. Let's get into it. One of the areas that we wanted to first look at was the area of searching. And searching is probably one of the fastest growing segments in the data market, with the likes of Google and whatnot, what's going on there. You may have heard about Web 2.0, not to mention things like data mining and areas like that. And in order to get high performance or instant access, and I think all of you know what instant access means. When you type in something from Google and you hit return, you want that answer right away. And of course, some of you may be thinking, well, I wonder how they do that. Well, one of the ways they do that is they don't service off a disk. So hit the button. So clearly the way to do it is to put everything in memory. But the memory needs to be huge. We're talking about We're talking about petabytes. That gets your attention. We're talking about petabytes in size of data, and even hot data is in the hundreds of terabytes in size. And then you start adding the amount of queries per second that you want to get in order to service your industry. And you were talking about server farms that are immense, and that's exactly what you see these companies building out. So we had so most people, other than just the biggest, next one please, is they don't put the whole index into memory. They just put a subset of it and hope you hit inside that subset. Next slide. So what we wanted to do is we want to look at that, and we want to sort of spread that apart a little bit and add the something that's sort of unique. And again, please. There you go. What we want to do is basically we want to create a new kind of DIMM. This is a memory DIMM that allows us to have the same kind of performance that you get out of DRAM, but with the capacity of hard disk at the DRAM level. One more time. So fundamentally, we're talking about terabytes of storage with nanosecond access speed, random access speed. And when I say nanosecond, and when I say random access speed, I'm talking about random access speed as you would see out of main memory. This is, any search anywhere can be anywhere in memory, and it's returned back to the user in a matter of nanoseconds. And this is exactly what Spansion is able to do with their EcoRAM, working with our partner Virident, who makes a gateway accelerator, if you will, memory controller accelerator, to make this memory work. So the bottom line out of this is you get instant access with massive database and very, very energy efficient. And so let's explore the energy efficiency. So one of the things that all of you know about DRAM is you have to power DRAM whether you're using it or not. And then when it actually is in access, it's quite a memory hog. And we're not talking about saving a couple of watts per server. We are talking about the second most power generation consumer in a server next to the CPU is actually the memory. And furthermore, as our CPU vendors like Intel and AMD get smarter and smarter in how they reduce their memory footprint and they add more cores to their chip, if anything, what is that has been driving is more memory inside the server, because you need more memory in order to drive those multiple cores. And it's very obvious if you look at a motherboard, you'll see a typical motherboard a few years ago would have 4 DIMM slots per CPU. Now all the new ones that are coming out have 8 DIMM slots per CPU. So if anything, the amount of memory inside the server is going up, and the amount of power that the server draws is also going up. So we wanted to basically approach that and reduce the memory by using Spansion's flash technology to build a DIMM that can take about has 1/8 of power consumption at the DIMM level. So I'll put it this way, 1/8 of power consumption on a per gigabyte level, then you can get out of DRAM. So we built a DIMM, this is fine. We built a DIMM that has 10 watts of power consumption, and that is comparable with, say, a gigabyte or 4 gigabyte DIMM, which also has 10 watts of power. Only instead of having 4 gigabytes on that DIMM, we can put 32 gigs on that DIMM. So the same amount of power that you have on a 4 gigabyte DIMM, we have a 32 gigabyte DIMM. Second thing, so that's 8 times the capacity, same power. And then the final thing about memory, and any of you know who come from the server space know that one of the things that fails in very large installations, next to disk will fail first. Probably the second thing that will fail is some memory somewhere will have a problem and the server application will go down. So you don't want to introduce 8 times the capacity and then tell your data center guy that you're going to have 8 times more failure out of each memory DIMM. So the beauty of using flash in this role is the fact that the reliability of that DIMM, even though it has 8 times the amount of capacity, has the same reliability as the 4 gigabyte DIMM that it replaced. So there's no penalty in reliability, there's a huge savings in power, and you have 8 times the density. Now, the benefit of that is basically you can put more memory inside the server than you could before. And you can see here that we're talking about a server that's sort of maxed out to these days, is probably using 4 gigabyte DIMMs, and they can get about 128 gigs out of a server with, let's say, 2 sockets. And we, out of that same server, can get 512 gigs. So today, we can put in a server, these are actually, I should clarify this, these are 4 socket servers, and we're using half of that server for our memory, and we can get a half a terabyte of memory inside of a server. And we've seen these servers actually be built that 1U. This is a 1U, very thin server that slides right in the rack, and that 1U server can have a half a terabyte of memory inside of it. So the bottom line out of that, we can replace 4 servers as far as memory capacity is concerned with one of our server, and that one server does not draw any more power than one of the other servers that replace. So we replace 4 times the capacity with a server that draws no more power than one of the servers that it replaces. A one-shot deal, and the answer is no. That if you look on the left side of the slide, a little schematic of a DIMM cell versus a mirror-bit. Mirror-bit is the NOR technology, just to be clear, that we are using for this. And I should say that this is a version of Spansion's NOR technology that has not been in the market yet. So no one has actually seen this. This is a very special version of the product. And it's a much simpler cell. So as you can see from the design, there's no capacitor or resistor in this cell. So the density over time is actually going to increase even more than it is today. If we can do a 32 gigabyte DIMM versus a 4 gigabyte DIMM today, tomorrow, even when we can double to 64 gig, and we'll actually be building 64 gigabyte DIMMs next year. And let's say that the 8 gigabytes are out there, and we can still have that same ratio of 8 to 1. We go the following year, we can increase again, and we can double, but it's unlikely that the DIMM memory guys are going to be able, the DRAM memory guys are going to be able to double as well. So as you can see over time, we can keep reducing the density, and we can now be 16 times the density that you can get out of a normal DRAM DIMM. So the future here is very bright as far as how this technology is going to move forward. So just want to conclude, this is just a picture of a server that has these DIMMs in it. I should tell you that we have this in alpha testing in a couple of major search engine sites already. We are not going to be announcing the product, so if anybody's going to ask you questions on pricing and availability and good things like that I'm sure all of you want to know, I really can't talk about that until we announce the product at the end of this year. It'll have the same reliability as a 4 gigabyte DIMM. Only it'll be offered as a 32 gigabyte. Because this is not your MLC type of NAND, it's not. We have a virtually infinite read reliability with no degradation whatsoever on anything we've ever been able to measure into the millions of read cycles. There is a write factor that you have to consider, but the write factor is buried in in some of the wear leveling and some of the other things that you've seen in other kinds of flash technology. But certainly in the areas that we're focusing in this for search, there's no effect whatsoever as far as degradation.